Hey, I'm Brianne Checketts.
I'm Ryan Alvarez,
I'm Mariano Correaga.
And I'm Ling Jet Chi.
and this is our COM 217 group project. Have you ever stared up at the starry night sky, wondering if there are worlds beyond our own? Well, the James Webb Telescope has allowed us to peer deeper into the cosmos than ever before. The telescope will likely contribute to many of our daily lives, since it's responsible for most of those pretty pictures that have been showing up in your Instagram feed. The value of the telescope is, however, much greater than that. According to an article by Quartz back in 2021, however, the project was about $9 billion over budget and 14 years late, which does put to question if such vast amounts of taxpayers' money is even worth it. That is why we're here to convince you that the ability of the James Webb Telescope to aid humanity in discovery is worth the high price of creation and operation. Our presentation will include a general overview of the characteristics of our project, as well as show our educational video.
All right, let's start by giving an introduction to our project. Why this topic and what is its significance? Well, we chose to educate our audience on the James Webb Telescope, not only because of its significance in recent news with the release of those new photos, but also because of its importance in the pursuit of discovery. We originally came up with the idea to present the telescope because it has significance within the areas of study for some of our group members. The telescope in general just has some extremely valuable insight that would be very difficult to obtain through human space travel.
Our target audience is the general public, but mainly ages 14 through 21. We effectively tailored our video to this audience through specific wording and making it concise to keep the audience engaged while still packing it full of information. The short and concise nature of the video is an attempt to replicate some of the short form media teenagers might see on social media. The video also provides images and graphics that aid in the overall understanding of the topics we aim to explain. Our video might be used in educational settings such as high school classrooms or university lecture halls to provide a quick overview of the James Webb Space Telescope.
Now, let's talk about the science communication principles that are used. Our intent is to inform our audience, so we use a topical organizational pattern paired with some audience analysis to help get our points across. Now that we have introduced some of the characteristics of our project, let's show our video. According to NASA.com, the James Webb Telescope is located 1.5 million kilometers from Earth, orbiting the Sun, although in the same orbit as the Earth. Specifically, what is known as the Lagrange point 2 or L2, a place without terrestrial interference, offering notable advantages for astronomical observation.
It specializes in infrared wavelengths, which are wavelengths around 0.6 to 27 microns. This is because telescopes' point is to see far into the distance and far into the past. This is due to light coming from other galaxies being redshifted. Redshifting occurs when a light source such as a galaxy or star is actually moving away from our own system. It works a lot like the Doppler effect for sound, where wavelengths will be stretched and compressed as they move towards and away from the subject that's measuring them. With these greater abilities to see farther into the infrared than Hubble, James Webb will be able to see things as minute as the atmospheric composition of exoplanets that could harbor life. Some of the new materials and new devices that have been put onto James Webb are things such as sunshield membrane materials, near-infrared and mid-infrared detectors for allowing to see farther into the infrared spectrum than Hubble can, lightweight cryogenic mirrors, shutter arrays, cryogenic detector readout application-specific integrated circuits, and many, many more.
Now that we talked about what the Space Telescope does, let's talk about the composition. The telescope is 6.5 meters or 21.3 feet across, with 18 hexagonal mirror plates that are gold-plated beryllium. Behind the body of the telescope, there is a sun shield that is approximately 22 meters by 12 meters, or the size of a tennis court. All these sections add up to a collection of 25 square meters, which can be calibrated to margins of 10 nanometers.
Now that we've talked about some of the dimensions and materials of the James Webb Space Telescope, let's talk about its downsides. The two biggest downsides to the telescope are the time and money it costs to build. The estimated price was 1 billion USD. The actual price ended up being around 10 billion USD, according to an article from Business Insider. The cost is so high because it's the largest and most powerful telescope created to date. It was supposed to launch in 2010, but got delayed many times, which cost a lot more money. They didn't want to waste the public's money by sending a non-functioning telescope into space and not being able to fix it. So in 2011, they almost completely got rid of the telescope as a project because of the budget kept growing and growing, and they weren't getting any closer to launch. Everything added to the telescope had to be invented, so the work required to build it was larger than normal. One example is $150 million and more than a decade to create the crowd cooler for one of the cameras because it needed to be negative 447 degrees Fahrenheit.
In the grand scheme of things, some of the important information we can learn about is other possible life-harboring planets.
Seeing as far back as the beginning of the universe until now, meaning we can predict how it will continue in the future. Some of the most detailed data to date.
In the future, it will be pointed at our own solar system so that we can learn more about planets that we haven't seen in detail yet, such as Neptune and Uranus.
And it will examine how galaxies change over time.
Now that you have seen our video, here's a recap of what we think.
Now, it should be more clear why the ability of the James Webb Telescope to aid humans in discovery is worth the high price of creation and operation. While the estimated price was close to $10 billion, the power it holds to help us peer into different universes that hold potentially habitable planets, as well as the insight it provides for planets in our own solar system, such as Neptune and Uranus, is extremely valuable because
the contribution of space exploration is not only the search for answers of scientific value, but also of personal development, as the more we know about what's up there, the more we learn about what's down here.
Thanks for listening.